that thing is called an arc. So what is arc? Arc is a portion of a curve. So a bending curve is called an arc. Now the task is that if we are given some curve like this one, this is just like a wire. You can see this is just like a wire. And the wire is from, let us say this is x-axis, and this one is now my y-axis. And that wire starts from A to another point, which is B. Now, how can I find the length of that wire? That is the task. The arc length is a procedure in which we will have a formula. With the help of that formula, we can find the length of any wire. So now look at here. We, in a similar procedure, we do a work very similar to that of the Riemann sum. Okay. So just like in the Riemann sum, we divide the whole curve into small portion. Let us say this is my point P naught. Now, let us say there is another point. That point is P1. There is another point. This point is P2. Let us say the coordinates of point P naught, that is x naught, y naught. The coordinates of point P1, that are x1, comma, y1. So from P naught to P1, we draw a line, and then we find the distance between P naught and P1. Let us say the first distance, which is d1, that is equal to, we are just using the distance formula. So according to the distance formula, we can write x1 minus x naught square plus y1 minus y naught square under the root. That is the distance formula between 2 points. Now, from point 1 to point 2, again, let us say point 2 is x2, comma, y2. Now I have to find the distance between P1 and P2. So I will say that is the distance D2. D2 is equal to under the root. Now I can write x2 minus x1 square plus y2 minus y1 whole square, like this one. So look at here, I am writing this in a different form. A different form mean, let me write here, we usually write y is equal to f of x. So the function f of x denoted by y. So now what I do here, let me write x1 as it is, x naught as it is, but here instead of y1 I am writing f of x1. Instead of y2 I am writing f of, okay, x naught instead of y naught whole square under the root. Similarly, I can write this formula as it is, like x2 minus x1 whole square plus, now I'm writing, instead of y2 I'm writing f of x2, and instead of y1 I'm writing f of x1 whole square under the root. In a similar procedure, we can generalize this and we can write dk. dk is equal to, under the root, I'm writing xk minus xk minus 1 whole square plus f of xk minus f of xk minus 1, and now this is whole square under the root. So a next procedure, we need to add all of these distances. So we can find our distance, the whole distance d. The whole distance d is equal to d1 plus d2 and plus up to dk. So now let us write this in the summation form. In the summation form, we write k is from 1 to n. Okay, this is actually the total distance will be up to k. So I am writing here, let me say this is our n distance. So we can write the n distance, just write n so that there will be no confusion. So now I can write the general term. The general term is dk. Okay, and if I put dk, dk will be equal to summation k is from 1 to n, and now here I am writing that distance, which is dk. dk is xk minus xk minus 1 whole square plus f of xk minus f of xk minus 1 whole square under the root. Okay, this is k minus 1. Now here let us say this is 1. I am doing something different. Now just concentrate on the board what I am doing now. I am using the mean value theorem. According to the mean value theorem, we know that f of xk minus f of xk minus 1 divided by xk minus xk minus 1, that is equal to f dash of ck, where ck is a point between xk comma xk minus 1. And if I further simplify this, from here I get f of xk minus f of xk minus 1, that is equal to f dash of ck into, now I'm writing, because this term will come here, so I'm writing xk minus xk minus 1. Now xk minus 1, that is delta x. If we take the same difference between all points, in that case we denote this by delta x. So we write from here, we write like this one. This implies f of xk minus f of xk minus 1, that is equal to f dash of ck into delta x. Let me write where delta x is equal to xk minus xk minus 1. So now we put all these values in 1. So let us put these values in 1. So from 1 we have d is equal to summation k is from 1 to n, and now look at here, xk minus 1, that is delta x. Okay, so I'm writing delta x square minus, sorry, this is plus. Now here f of xk, look at this term, f of xk minus f of xk minus 1. So that is equal to f dash of ck into delta x, and that is whole square under the root. Now we can take delta x as common from these two terms. So if we take delta x whole square as common, then we can also take it outside of the integration. So from here we write, look at here, summation k is from 1 to n, And now I'm writing under the root. Now look at here. This is 1 plus. This one is f dash of ck square whole into delta x square. Because I'm taking delta x square as a common from the first term and the second term. And now if I remove delta x whole square under the root is delta x. So just I want to write a little more simple form of that thing. So let me write case from 1 to n. Now look at here. This is 1 plus f dash of ck whole square under the root. And now delta x goes outside of the root. So in the next step, let us take limits. Limits delta x approaches to 0, or we can say n approaches to infinity. Summation, let me write the remaining things. K is from 1 to n, okay? And now I'm writing here 1 plus, okay. 1 plus f dash of ck whole square under the root n to delta x. And we know that if we take these limits, the right hand side is now equal to integration is from a to b 1 plus f dash of x whole square under the root n to dx. So that is the required formula to find the arc length of the curve. So now let me write this in this form. Sometime we denote this by s, sometime we denote it by d. So I'm writing that s is equal to integration s from a to b, and this is under the root 1 plus f dash of x whole square into dx. So you must remember this formula. That is the required formula which we need to find by using the Riemann sum. Now, if we want to take the arc length parallel to the y-axis, because you can see all the functions are functions of x. So if there is a function, let me say we have f of y, the function is a function of y, and the limits are from c to d, and we need to find the arc length. In that case, the arc length s is equal to integration from c to d under the root 1 plus f dash of y whole square into dy. That is the basic formula which we shall use to find the arc length is a function of a function if the function is given in terms of y. Find the arc length of f of x, which is equal to 4 by 3 x power 3 by 2. And the limits are also given, which are from 2 to 6. So here you can see it is a function of x. So what we should do now, let us write the arc length formula. S is equal to integration is from a to b under the root 1 plus f dash of x. F dash of x means differentiation of f of x whole square into dx. That is the basic formula, okay? Now the limits are given. It means the first one is a, the second one is b. Very simple. But what I need to differentiate the function. So let us differentiate the function. I need to find f dash of x, okay? So let us differentiate this. This is 4 by 3 as it is. If I differentiate, I must write 3 by 2 x power 3 by 2 minus 1. Let us simplify a little more. From here, 3 will cancel with 3 and 2 2s are 4. So I have 2x power. From here, I get 1 over 2. You can see if you take the LCM of 3 by 2 minus 1, you will get 1 by 2. Let us put these values in formula number 1. So from formula number 1, we have S is equal to integration from 2 to 6 because A is 2, B is 6. And here I am writing 1 plus f dash. What is f dash of x? That is 2x whole power 1 over 2 and its square under the root into dx. So it's very simple. Just I am putting the values. And now the next task is to simplify this. So you can see 2, from here I can get that s is equal to integration is from 2 to 6, 1 plus 2 square is 4. X under root or x power 1 over 2 square is x. And now I'm writing under the root here into dx. The next task is to integrate it. So look at again. Now I'm going here. Look at here. I'm writing s is equal to integration is from 2 to 6. And here instead of under root, I'm writing 1 plus 4x power 1 over 2 into dx. There is a very basic rule of integration. The rule is there. If we have some function and there is some power of this, it means we have f power n, and with multiplication there is differentiation of f. Let me write f dash into dx. Then its integration is f power n plus 1 divided by n plus 1. That is a very simple rule. Now look at here. Here f, that is 1 plus 4x. And if I differentiate this, its differentiation is 4. So let us multiply and divide by 4. So now we have f power n is 1 over 2. Using that rule, I can write 1 over 4. And now integration of this is 1 plus 4x whole power 1 over 2 plus 1 divided by 1 over 2 plus 1. The limits are from 2 to 6. Let us simplify this. So we have 1 over 4. 1 over 2 plus 1. From this we get 3 by 2. If I take it up, it will reverse. So I can write 2 by 3. It will become 2 by 3. And the limits and the function is as it is 1 plus 4x. And the power here is again 3 by 2. Because 1 over 2 plus 1, that is 3 by 2. The limits are from 2 to 6. Now what we have to do? We have to put the upper limit minus the lower limit. So from here we have 2 and 2 2s are 4. So I am writing it here. That is 1 over 6. Okay. And now let us use the upper limit. So if I use the upper limit, I will write 1 plus 4 into 6. 4 into 6 is 24. I am writing is directly. Okay. The power is 3 by 2 minus 1 plus 4 into 2. 4 2s are is 8. I am writing the power, which is 3 by 2. Let us simplify a little more. So from this we have 1 over 6. Look at here. 1 plus 24, that is 25. So I can write 25 as 5 power 2 because 5 5s are is 25. So I am writing this 5 power 2 into 3 by 2 minus. Now 1 plus 8, that is 9. So I can write 9 as 3 power 2. And let me write in multiplication 3 by 2. Let us simplify this. From here, I can get this thing. And if I further simplify, I have 1 over 6. Now I have 5 power 3. So what is 5 power 3? That is 125 minus. I have 3 power 3. That is 27. And now let us subtract 27 from 125. So if I subtract it, I get 97. I think 5, 6, 7. So I get 98. I think that is 98. What we get if I subtract 27 from 125? What we get? I'm asking.
8.
What we get if I subtract 120 from 125, 127?
98.
That is 98. So can we further simplify this? 3 twos are 6. Okay. 4 twos are 8. 9 twos are 18. So from here we get that the arc length is 49 divided by 3. And that is the required solution. Let us explain it once again what we do here. Look at the question. In the question we have to find the arc length of this function from 2 to 6. So as we know now that we shall use this formula. In this formula there is f dash. F dash means we need differentiation of this function. So just differentiate this. Then put the value of f dash here and simplify. After simplification, you can integrate and you can further use the limits and get the solution, which is 49 by 3. Now, if you have any question or doubt, please don't hesitate. Just ask the question.
सर एक्सक्यूज मी
Yeah, please.
सर ये आपने 4 से मल्टीप्लाई और डिवाइड क्यों किया है?
Okay, that is actually I have explained here. There is a rule. The rule is integration of f power n into f dash is equal to f power n plus 1 divided by n plus 1 plus c. To use this rule, I need differentiation of this function here. Now look at here. The function in this case is 1 plus 4x. But here I need f dash. This is f power 1 over 2 and I need f dash here to use this rule. So that is why differentiation of 1 plus 4x is 4. If I want to differentiate, I get 4. So I need its differentiation. That is why I multiply and divide by 4. Now it is suitable for this rule and I can use that. Is it clear now?
Yes, sir.
To write the formula of arc length, so the formula is S is equal to integration is from A to B. And instead of under root, now I'm writing 1 over 2. Okay, so I'm writing 1 plus f dash of x whole square whole power 1 over 2 into dx. Okay, let me see. There is someone in the lobby. I have to enter him. Okay, there are two guests. Okay, Muskan and the other is Waqar Ahmad.
Yes, sir.
Okay, so now the task is to find the arc length. So what we should do, look at the formula. What the formula needs, I'm asking, what is the data which is needed for formula number 1? I'm asking, what do you need for the formula?
Sir, f dash of x.
Derivative, sir. Derivative,
Good.
sir.
Good. The first thing we need the derivative, f dash. What is the second thing? We have f of x. So from f of x, we can obtain f dash of x and we can put it here. There is also A and B. We must
Limits
put the value
0
of
and
A
pi
and
by
the
0
value
to
of
pi
B.
by 4.
Yes.
So
Yes,
what is
sir.
the value of A?
0,
0
sir.
0
Good. And what is the value of B?
pi
5
by
by
4.
4, sir.
pi by 4.
Great. So that I'm asking. Look at here. This is A, this is B. And now let us put the values. So I'm writing S is equal to integration is from 0 to pi by 4. Now there is 1 plus, but first of all, let me write the value of f dash, okay? And then I can put it here. So f dash of x, let us differentiate. Differentiation of log of some function, that is 1 over that function, which is cos x, and then differentiation of cos x. Let me write it here. D by dx of ln f, that is equal to 1 over f differentiation of f. So I'm using that rule, okay? From this rule, I get f dash of x, which is equal to 1 over cos x. Differentiation of cos is minus sine. So here I am writing minus sine x. This is sine by cos. So I can also write that this is, okay, let me write as it is, okay? Let me write it as it is. Minus sine x divided by cos x. Now we need to put these values in formula number 1. So we have S is
सर इसमें
equal
हम
to yeah, do
tan
you
x,
ask something?
yes sir, tan x नहीं लिख सकते वो
We
problem
can write minus tangent x. Both are okay. It's your choice, okay? It's your
yes
choice.
sir.
Okay, so now I'm writing 1 plus, let us write the tangent x. Actually, she like tangent x, so we can write like this one, okay? Now 1 plus f dash. F dash is minus tangent x whole square. Power is 1 over 2 into dx. Limits are from 0 to pi by 4. And from this we have s is equal to integration is from 0 to pi by 4. This is 1 plus tangent square x into dx. Now let me tell you about one formula, that 1 plus tangent square theta is equal to secant square theta. That is the basic formula, okay? So we replace 1 plus tangent x by secant square x. There is 1 over 2 also. Let us do that. So I am writing s is equal to 0 to pi by 4. And now look at here. Here I am writing secant square x whole power 1 over 2 dx. And from this I can write integration is from 0 to pi by 4. Secant square x into dx. Sorry, the square will remove. 2 whole power 1 over 2. 2 will cancel with 2. And now integration of secant x is log of secant x plus tangent x. That is the basic formula for integration of secant x. The limits are from 0 to pi by 4. Now the next task is to put pi by 4 and then 0. So let us do that. So I'm writing here that this is equal to log of secant pi by 4 minus tangent, sorry, this is plus, tangent pi by 4. Now minus log of secant 0 plus tangent 0. Now use calculator and tell me the value. Now I'm just giving you this task. What is secant pi by 4? Just tell me the value of secant pi by 4. I'm asking.
Sir, don't we use log of secant x plus 10x in the mod form?
In the mod form, yeah, you can use, you can do, but do is directly, okay? Just find the solution. Tell me what is the value of secant pi by 4?
Radical 2.
What?
Radical
Square root of 2. Let me write square root of 2 here. Now plus, what is the value of tangent pi by 4?
1.
Good, that is 1. Minus log of, what is the value of secant 0?
1.
What?
1.
1?
Yes, sir.
Are you sure?
Yes,
Yes.
sir.
Okay, that is 1. What is the value of tangent 0?
0.
0.
Great.
0.
Now look at here. From this I get ln, let me write it here, ln 1 plus under root 2 minus ln 1. And from this I can get s is equal to log of 1 plus under root 2, because log 1 is 0, because ln 1 is equal to 0. So that is the required solution. That's all.